Welcome to Learnpedia, the 24/7 JEE and NEET resource at your fingertips. Now, take a look at this actual JEE question and see if you can answer it. If you think you got the answer, post it in the comment section below. To know the best way to solve this question, continue watching this video.
Now a function f of x is said to have a local maximum. Localized means with respect to a point in and around the point. It's not the complete domain of the function but only with respect to a point. So said to have a local maximum at the point x equal to a if f of x is less than f of a for all x belongs to a minus delta to a plus delta. Now what is this interval a minus delta to a plus delta? When a is a real number and delta is a positive real number, as small as possible. The more smaller it becomes, we are restricting our x only to a simple neighborhood of a, isn't it? This interval a minus delta to a plus delta is nothing but the neighborhood of a, right? So within the neighborhood of a, if all the functional values of f of x are less than that of f of a, then we say this f of a value is the local maximum. Let's see this graphically. On x-axis, at a point a in the domain, we are defining an interval on either side of a as close as possible to a. That's what we call the neighborhood of a, right? So in the neighborhood, that is from a minus delta to a, if you look at the left side neighborhood, what does this consist of? The values from a minus delta to a. Whenever x belongs to a minus delta to a, if you look at, that means if I take any value of x between these two, then the corresponding functional value being, this is the height of the point x, isn't it? Then this f of x is clearly less than that of our f of a value, isn't it? So in this, throughout this interval, because I have f of x values are less than f of a, right? On the left neighborhood, wherever we take a point x, then the height of such a point, that is f of x, would be definitely less than that of this height f of a. Then similarly, extend it to the right neighborhood. Now what is right neighborhood of a? Now it is starting from a and going up to a plus delta. That is on this side also, if you take any point x in the domain and then take the functional value corresponding to that point x, then this height, which is f of x, is again less than that of f of a. This is the height of the point, whereas f of a is this height. So which is higher? F of a is of more high than that of f of x. So look at this graph now. From a minus delta to a plus delta, that is within the neighborhood of a, wherever I take x value, whenever x belongs to a plus delta, then also I am having f of x value is less than that of f of a value. So on both the left hand neighborhood and right hand neighborhood, if the functional values are below that of f of a, then we say f of a is the maximum within the locality of a. That's why we called it as local maximum. The word local itself suggests that you are only within very closer range of a. Within the localities of, within the neighborhoods of a, the function has a maximum value of f of a, right? Such a maximum which is defined only in a close neighborhood of a is called the local maximum. So what is the term local maximum denote? Simply saying it is the maximum in the neighborhood of a, that's all. So simply local maximum at a point x equal to a implies, what does it mean? It is the maximum of f of x in a closed neighborhood of a, that's all, right? Because we are restricting our range only from a minus delta to a plus delta, we are calling this maximum as local maximum, right? Let's look at what do we mean by local minimum. Follows the same terminology. The minimum evaluated in a neighborhood of a, that is when x is from a minus delta to a plus delta, if the minimum is evaluated within this neighborhood, this value a minus delta to a plus delta is nothing but the neighborhood of a. Within the neighborhood of a, the minimum exists, then such a minimum is called local minimum. Now when do we say there is a minimum? If every functional value of f of x is more than that of f of a, where in the neighborhood of a, where delta is a positive quantity and is as small as possible, then a minus delta to a plus delta defines a neighborhood which is very close region in and around a. Then within that region, if every functional value is more than that of f of a, then f of a is said to have a local minimum at the point x equal to a. How does the graphical explanation go? When we take a graph and consider a point a in the domain, let's define two neighborhoods. One is the left neighborhood. How will be the left neighborhood of a? It would be simply a minus delta to a. Now look at the graph from a minus delta to a. Within this a minus delta to a, wherever I locate a point x, then this point being f of a, then the height of this point, this is f of x. Now which of these f of x and f of a, which of them is of more higher? F of x is more high than that of f of a. Then wherever you observe the point in the left neighborhood, will the functional values be more than that of f of a? Right? Then whenever x is within a minus delta to a, then clearly f of x is greater than that of f of a. Now similarly, what happens when we consider the right neighborhood of a? The right neighborhood is nothing but starts from a and goes up to a plus delta. Right? Now here also from a to a plus delta, wherever we pick a point variable x here and observe the corresponding height of the point on the graph, then this height is more than that of f of a, isn't it? Then on the right neighborhood also, that is whenever the x is from a to a plus delta also, we have our f of x value, that is functional values are more than that of f of a. Then if every functional value is more than that of f of a and a comma f of a is a point on the graph, then shall we say f of a is the least value, that is the minimum value. So this is a minimum value, but a minimum value observed only from a minus delta to a plus delta. Then such a value of minimum which is measured only in a close neighborhood of a is called local minimum, that is a minimum localized to a. Right? Therefore, can we conclude that local minimum at x equal to a is the same as the minimum value of f of x in a neighborhood of a? Isn't it? It is the minimum, but the minimum not on the whole of the graph, but only within a neighborhood of a. Now a minimum evaluated in the neighborhood of a is called the local minimum at x equal to a.
I hope you can now answer the question. Take a look at the solution here. Hit the bell icon below to subscribe to the Learnpedia channel and to learn more through more such interesting videos. Learnpedia's JEE and NEET prep tools contain more than 4,000 videos and over 20,000 solved examples. These can be accessed online through our website or offline through an SD card or a pen drive. To buy now, visit www.learnpedia.in. You can also experience a free demo of our product before buying.